Alright, so now we gotta talk about the math side of pH, and so we're gonna have some vocabulary. So it's kind of vocabulary, a lot of it's symbols and notation, not really words, but it's all connected. So our base formula, not base for basic, but base for standard, is pH is the negative log of our hydronium or hydrogen concentration. Anything in brackets means concentration. So if I have concentration of H3O or hydrogen, that is our concentration of hydrogen ions. And if you remember from a million years ago, semester 1, concentration, that's another word, that's the definition of molarity. So if you see something like this, it means the concentration of hydrogen ions is 1 times 10 to the negative 2 molar. And we can use that to calculate the pH. Just wait and see. So we have Kw, that's our equilibrium constant, assuming that our water is at a neutral pH. And that's this formula right here. So we have our concentration of hydrogen ions, our concentration of hydroxide ions, and it's all equal to 1 times 10 to the 14. As we've talked about, pH relates to our concentration of H plus or H3O ions, whereas pOH relates to our concentration of OH ions. Because I never heard of pOH. It exists, we just don't use it as much. pH is usually the standard, because pH and pOH have a relationship where they add up to 14. If we look, our pH and our Kw, our pOH and our sum equal to 14, and our Kw has an exponent of 14. And hey, look, our logarithms, if we break those down, we've got 10 to the negative pH to the negative pOH. So there's an inverse relationship between these guys. So we got some memes. We have pH always getting all of the attention, and pOH forever alone basking in the shadow of pH. To take a minute, what's the difference between pH and pOH? Go rewind the video if you forgot. So now let's do some math. So they give us the hydrogen concentration is 1 times 10 to the negative 5. They want the pH, the pOH, and the hydroxide concentration. So first we got to pick a formula. Out of all these formulas, I need to pick one that has both my hydrogen concentration and my pH. Let's see, it would be this one and that one. However, if I choose this one, I don't have to derive anything because pH is already by itself. This one down here, pH is in the exponent, so if I wanted to know it, I would have to do extra math. So let's see, if my pH is equal to negative log of my hydrogen concentration, that means I would have negative log of 1 times 10 to the negative 5. And you know, let's go use a calculator to find out what that is. Negative log 1 times 10 to the negative 5. And that equals 5. So that means that my pH is equal to 5. And if we remember, that means that our compound is acidic, because the pH is less than 7. So now we got to figure out the pOH. Well, I don't have a formula that has both my concentration of H and pOH. But I do have a formula that has pH and pOH. Since we know the pH, we can plug it in and solve for the pOH. So pH plus pOH is 14. that means I have 5 plus POH is 14. We take off the 5s. My POH is 9. If you need to go back and use a calculator, you can, but I'm not going to go do that. So just from this one given, we can already find out 2 unknowns, and obviously we're going to find the third unknown. So now we got to pick a formula to find the OH. So I could use this formula, plug in my hydrogen concentration, and solve for the OH. But because I already know my POH, it would be a lot easier to just plug it into this one. So that would mean that my OH concentration is equal to 10 to the negative POH. So we'll go plug that in, and we get 10 to the negative 9. And if we need to check ourselves, if we do our hydroxide concentration multiplied by our hydrogen concentration, we get the Kw back. Negative 5 and negative 19 give us that negative 14. If we check ourselves again, the 5 and the 9 give us our 14 right there. So let's try another one. We want to know what's the POH given the pH. Take a minute, think about what formula would you want to use. Which one has both the pH and the POH? Our very first one. So that would put us at 3.7 is equal to 14, plus the POH is equal to 14. And when we subtract off the 13.7, my POH is equal to 0.3. And that's it. That's the answer. The end. Here's another one. We want to know the hydrogen concentration, again given the pH. So which formula would best give me hydrogen concentration if I know the pH? Well, that would be this one. Let's see, my hydrogen concentration is equal to 10 to the negative pH. So that would be 10 to the negative 12.1. The end. That's your answer. All right. This time, they give us the pH, but they want to know the OH. Well, because I don't have very many combination formulas, this is the only combination formula between pH and POH, we're going to have to use 2 formulas to get to this answer. We'll use this one to get our POH, and then we'll use this one to get the hydroxide concentration. Let's see, so number 1, we'll have pH plus POH is 14. And I'll plug in my pH. Subtract off what we know. Let's see, 14 minus 4.5 would be 9.5. So then now we can plug it into here because I have the pOH. So my molarity, or my concentration of OH ions, is 10 to the negative 9.5. All right, we got another one. Let's see, College Board has you use pH to find the OH concentration. Is that illegal? No, we just did that. We can do that again. All right, so given the pH strip in the circle, how can we find the OH concentration? Well, step one, we got to figure out what does this mean? Well, if I compare everything on the scale, it looks most like a pH of 10. So we're going to say the pH is 10. So if I want to convert from pH to pOH, I got to use formula number 1. So my pOH is 4. You can go back and do the long math. The pOH is 4. But I don't want the pOH. I want the concentration of OH. So now I go back and I plug that into the formula. In the end, our concentration of hydrogen ions is 10 to the negative 4. You might see it as 1 times 10 to the negative 4. Same thing. We can put molar if we want to put units. All the same thing. So this one's slightly more difficult. Even though it's multiple choice, I promise you it's a little bit more difficult. You're going to get tricked by it, so don't get tricked. So they tell us the pOH of a solution is 9. They want to know which one's correct. Let me see. They give us options of hydroxide concentrations, options of hydrogen concentrations. Well, the hydroxide concentration is easier to find from the pOH, so let's start there. We'll start with this one. So my concentration of OH is 10 to the negative 9. Alright, so that's true. That's false. However, we should probably check some of these other ones just to be safe. Alright, if my pOH is 9, what's my pH? We'll find out if this is acidic or basic. And so here, I just manually did it. I sent the pOH to the other side. And that's where I got the 14 minus 9. 14 minus 9 is 5. So let's see, pH with a 5. That's acidic because it's less than 7. Well, this says the solution is basic, so that's false. So it can't be C. So now we have to go back and we have to find the hydrogen concentration. But that's easy. We're going to use that formula right there. And our pH right here. So my concentration of hydrogens is equal to 10 to the negative 5. So let's see, it's not that one. That checks out, that checks out. So we did B. So just because one part of the question is true doesn't mean the other part is. You kind of have to check them all. Alright, here's practically the same question, just a different variable. They give us the hydrogen concentration, and they want to know which is correct. Well, let's start with the pH, because that can tell us if this is true, and if any of these are true. Let's see, if I want to get the pH, I'm going to have to use this formula right here. pH is equal to negative log of the hydrogen concentration negative log of 1 times 10 to the negative 10. So we can go plug that into our calculator. If you haven't figured it out in the pattern, I mean, there is a pattern, but we can go check with the calculator. Negative log 1 times 10 to the negative 10. So our answer is 10. So that means that our pH is 10, which is basic. So let's see, it's not acidic, it's basic. All right, so now let's see, our options are pOH is 10, concentration is 1 times 10 to the minus 4. Well, let's see, if my pH is 10, my pOH is 4, because they've got to add up to 14 based on that formula. So that's not true. So by process of elimination, it's got to be A. We're not even going to do the calculation because we don't have to, because all the other ones are false. I mean, you can plug it into that one, and you do. You get 10 to the minus 4. So here's your exit ticket. When you're done, go ahead and send it to me so I know that you watched the video.